It's your turn.
All right, so thank you first of all to Paul for saving this presentation. Am I really the only one that only has an HDMI output of the presenters? Was any? It didn't work for you?
No. You have to plug the HDMI into the. We think the cable's too long for the digital signal from an HDMI.
Anyway, okay, that was my difficulty. Wasn't able to connect. So we shuffled everything over to this computer, and fortunately it's working. It's always nice when you get at least a little bit of good luck, and the good luck is that it's up on the screen. So we can proceed. I can proceed with this. I guess it was sort of a stroke of luck that I decided to write my own presentation script to throw this up on the screen, because if I had done it in something like PowerPoint, I don't know, I may have been out of luck on a foreign computer here. So that actually worked out, I guess, pretty well. But my presentation is about coroutines. I introduced myself first. My name is Nathan Coulter. I'm from Salt Lake City, Utah. I started using TCL in 2011. I had been programming in Python, and I'd had a few encounters with TCL, and when I finally sat down and looked at it, I really fell for it. So I get a chance to use it every day, which is great. All right, so I have been using coroutines and trying to find patterns that are useful with coroutines, and they're a great thing. First of all, I want to say thank you to Miguel. Miguel is one of those brilliant people that it seems that TCL has a history of this. They burst onto the scene, they give us incredible things, and they leave these things, gifts to the community, and then they're gone. Miguel passed away. For me, it was unexpected 2 weeks ago. Very sorry that he's gone. But he gave us coroutines, and coroutines are an amazing thing. So something, I guess, that we'll always have to remember Miguel by. First of all, I decided to throw in a couple of slides here. Basic introduction to coroutines. What is a coroutine? Well, essentially, a coroutine is a pausable call stack. TCL has a history of multitasking within a single process, which has always been one of those outstanding things that we brag about. Other languages are finally catching up. Of course, we've had Node.js in the last few years that's gotten a lot of press about this same feature, this ability to do what TCL's been able to do for a long time. And coroutines are a nice extension of that. It's a new way to multitask in a single process. In the past, I guess traditionally in TCL, what you've had is a sort of a callback situation. We've got the event loop, of course, and commands that accept callbacks, and that's pretty much how we do multitasking in a single process. With coroutines, we have that same situation, but now we have an entire call stack that can just pause in the middle of an iteration, in the middle of a while or a for loop, and it can just yield and say, call me back later on when you want to. This is all cooperative. There's no way to preemptively tell a coroutine context to stop from the outside, but cooperatively, coroutines can work together within a single process, calling each other as they want to. So this is a simple example. This is just a counter. We have one procedure, and the procedure is just a loop that yields. And when it yields, that means that the flow returns to the caller of the coroutine. In this case, we're creating two coroutines, C1 and C2, after which you can call C1 and C2, which are commands. Each time you call C1, for example, you enter the coroutine context, and you end up right back at the yield. So that's how they work. This is a slightly more complex example. In this case, we've got the term lambda. That's sort of foreign for TCL. It's really just a apply. It's a command which is the closest thing that we have to what other languages would call a lambda. It works great in TCL. And when you combine it with a coroutine, essentially what you're doing here is, it's exactly the same thing that we had on the previous slide, but we're not defining a procedure called P1. We've used apply to save ourselves the pain of defining P1 in a namespace. So that's essentially, when we're talking about coroutines with lambdas, it's something like this. All right, so YCL Coro Relay. This is the motivation for the presentation, and I'll explain why I called the presentation YCL, or Coro is the new main, in a moment. But what does this do? YCL Coro Relay, coroutines schedule calls to other coroutines, and eventually they receive the result of each of those orders. So eventually is the key word there. That means that the event loop is involved. This is essentially a strategy by which you're in a coroutine context. You want to farm work out. Maybe it's something that's going to take a while, but you want to farm some work out and get a result later on. And maybe you want to farm. Maybe you want to dispatch several things, and then later on get all of those results. And in your coroutine context, wait until they all come in. So that's what this does. The primitives that YCL Coro Relay provides there are two on the service side and two on the client side. So this is it's designed according to, I guess, a pizza delivery model, where you are sitting at home and you want a pizza, and you call and you order the pizza, and in the meantime you go get back to whatever you're doing, and eventually you get your pizza. So on the service side, we have a server or a coroutine. The service would be a coroutine. The client would be a coroutine. So the service would call accept, and eventually it will get an incoming call, and it will do something, and it will deliver a result. Deliver is not actually a command. It's an argument that's received through the accept function, but accept, deliver. And then the client makes an order and receives an order. All right, so where are the yield points? They're in accept on the server side, and they're in order on the client side. And the event loop sits in between. So things keep chugging along, managed by the event loop. Another convenience function or command that is provided is call. With this command, you can call any other command, wait for it to complete, and then receive an order, receive the result. And again, the event loop is involved, but the command that you're calling doesn't have to know anything about YCL Coro Relay. It can be an arbitrary command. It doesn't have to be following. It's just a command. But YCL Coro Relay manages it for the caller and inserts the event loop in between. It's towards the end, there will be an example of why you might want to do this. All right, a brief discussion about the word yield. So yield is the command that pauses a coroutine context. And something interesting about the word yield is it's got two meanings in English, as well as two meanings technically, the way coroutine uses it. The first sense of yield is what you might do at a roundabout. You yield because you don't want to get run over, and you want to be a good citizen. But you're not producing anything. You're just stopping and allowing whatever else is happening on the street to happen. In another sense, yield means that, and I should have said return here. I think a later version used the word return, but yield, an investment might yield a return. It produces something. Now in TCL we have the same situation. We have coroutines that yield or yield, and this is kind of relevant to YCL Coro Relay because YCL Coro Relay eschews the use of yield to produce something. it simply uses yield to pause the coroutine because it needs to get back to the event loop. And if you're going to yield to the event loop, well, the event loop doesn't have a mechanism to pass along what it receives as a result of calling a command. And so we don't use yield for that. And YCL Coro Relay doesn't use yield to produce results. And in a sense, that's one of the things that people get excited about with coroutines, is iteratively producing results. But it's also useful to multitask, and yield has sort of both of these capabilities. All right, so this system, Coro Relay, has to do something instead of yield. It can't yield the result, so instead that's why it provides the primitive deliver. Yield is just for pausing, and deliver is for producing. Okay, I'm going to skip over that and get to this example. This is what main might look like. If you write it as a coroutine, it looks like this, and we have the lambda, the apply command in there, and then you have just a main procedure. And if you write it like this, since you're in a coroutine context, if you were to call another command that wants to yield and wants to assume that it's in a coroutine context, it will work. If we were to just write, proc main, as we're all used to doing, then any procedure which assumes that it's in a coroutine context is going to be incompatible, because it's not going to be in a coroutine context. And that's the reason the presentation is called Coroutine is the New Main, because it's very, very useful to, if commands can assume that they're in a coroutine context, they can use yield, and that leads to all sorts of interesting patterns. So that's kind of the implication of using coroutines and using yield. Is that's one direction that standard libraries might go. They might just 10 years ago, or 10 years from now, maybe TCL lib will just make the assumption that it's always running in a coroutine. Maybe it won't. It's wishful thinking, but it would yield interesting new patterns. Okay, so a producer. This is a little bit more meaty here, but this would be a command that takes a list and just iterates through the values in the list. And you can see that the first thing it does is it accepts something, and this is in the iteration. It will accept something, so that's where it's just waiting. And once it gets something, it makes a delivery. So that's what a producer would look like. A consumer would order something, go about its business, and when it wants to get the result, it will receive that result, and that's the point where it will pause until the result comes in. Scatter-gather example would be perhaps two loops, one after the other, as a basic toy example, where you're sending off a bunch of orders, and then you're collecting all of those orders. Now, why would you do this in a single process? Well, I don't know. Maybe I actually have used this for certain things. It particularly can be useful with I/O combined with things that you're waiting for to come in on I/O channels. Another convenience function is YCL Coro Relay iter. That's getting long, but you can probably imagine from this simple example, you can see clearly that this is another one of those control structures that people like to write in TCL, and this is a control structure that just lets you iterate through a coroutine which is delivering things with the event loop kind of hidden back there behind the scenes. One nice feature of this system is error propagation. You make an order, and when it comes in, if there's been a problem, it's handy to see what the problem is, of course, and this system does provide for that. The receive command, if there has been an error over in the service, it will create the error in the receiver, and it will just look and act like a typical TCL error. So that's actually, I think, a pretty nice feature, the ability to see that. Currently, the call stack information sort of cuts off at the you only see the service side, but that's something that could be improved. There's nothing technical preventing the system from providing a full call stack across order and receive calls. All right, I may skip this one in the interest of saving time. We'll come back to that. This is an interesting one, and this one will be one that Richard will be interested in. Now he's looking. And the reason this is interesting from an SQLite standpoint is that what we have here is, I'll dissect this a little bit. It's kind of dense code. And this is, I hope I can improve this, or this can be improved. The code does get a little bit dense, and I hope that's just at the design stage, and that we can create sugar to make this a little easier on the eyes. But yeah, currently it does get a little dense. The first line, we're setting up a coroutine. In the second line, this is a service, and it's accepting an order. And then we get to a function, a command that really, it comes from a different system. It's a system I have called Eve, which is an entity attribute value system. It's a way of just throwing things in a database. But it's got a query function. So the database is a sort of, logically, it's a hierarchy of objects. And this query function descends through that hierarchy, and it delivers the things it finds. Now that query function is an SQLite query under the hood here, behind this kind of made-up query language. And this script, I don't think I can highlight here, but after the word eval record, there's a script, and that's a script which is evaluated. It's a SQLite evaluation, the DB command, essentially. But we have a yield in there. The deliver line is hiding a yield, and so the SQLite query is evaluating a script, iteratively evaluating a script through the query results and yielding. And it works. And I don't even know why it works. I didn't expect it to work. I thought it would fail. But I threw it in there, and it worked, and it's fantastic. It's brilliant, because it's sort of along the lines of what Christian was talking about. It's a way to plow through the contents of a database with the event loop involved in a sort of multitasking manner, and get the results out one by one. So dense, but really kind of interesting what you can do with the combination of these great things that we have. Okay, that is an excerpt from the previous slide, so I'll skip it. This is another long slide. The only thing that really is worth putting your eyes on here is down towards the bottom, there is a relay call and a relay receive. This scale text procedure is actually the procedure that's running this presentation. This presentation is a script that I wrote over the weekend and then spent the entire week frantically playing with to do this presentation, because I thought it would be fun to have a presentation script that was actually using Coro Relay to throw the slides up on the screen. And this relay call down at the bottom is what allows TK to breathe. Lets TK render the font, re-render the slide. So it is in a while loop. So this procedure is scaling the text. You can only see a little bit of it here because I pre-scaled all these slides sitting over there a moment ago, because I found out that the Macintosh here was scaling just incredibly slowly. one of the hazards of switching hardware was can be unexpected things like that. But you can see it's bouncing. The words are bouncing up and then down. They're scaling up, and then they're scaling down just to make sure they didn't go too far. And that is that's this procedure right here, which is at the end of each iteration, making a call through EuroTcl Coro Relay, and then TK does its thing, and the iteration continues. Okay, so in a nutshell, in conclusion, EuroTcl Coro Relay is an analog to what you might do if you were inclined to maybe fire off a bunch of threads to do some concurrent processing. Now, in this case, in the case of Coro Relay, it won't be necessarily concurrent in the process, but you can combine it with I/O, and you can do all of that in one process using coroutines to multitask. Okay, any questions?
So you start your main routine as a coroutine, but if you have TK, then you have a lot of callbacks that you may also want to do as a coroutine. How do you propose to do that?
Yeah, so the way it ends up getting organized is in that case, you'll strategically figure out points where you want to create coroutines that are interacting with TK. So you're firing off, the main coroutine is instantiating other coroutines that are interacting with TK, and then possibly back with the main coroutine. So you get a proliferation of coroutines. It's similar to calling commands. It's just that coroutines are a little bit more persistent. It takes some discovering to figure out. It's a new pattern, so there's a lot of discovering to be done with how to use these.
Okay, so talking about proliferation of coroutines, did you come upon any patterns how to do garbage collection upon your coroutines?
In what I've done so far, and by the way, I've written an can anybody off the top of your head name a event-enabled command built in to TCL that is kind of painful to use? Okay, it's HTTP. HTTP has a long history of being exacerbating. So I've written an HTTP client using Coro Relay, and my intention is that it's perhaps a replacement for the current HTTP command that we have. And as opposed to the current situation where it's providing a callback, this library, which you can check out in the EuroTcl repository, just iterates through responses to requests. And so it's all coroutine driven. But I rely, when I was doing this, and as I've used this library more and more, I essentially rely on deleting coroutines when I've decided, when the caller decides it's done, or when the coroutine dies, and that's the garbage collection.
Observation and a comment. The observation is I don't see package required TLS there. Just saying.
I think that's often in a sister file.
The observation is in the Mac world, with all their development paradigms, they're moving away from callbacks, or what they call protocols, to everything's done by blocks of code passed in, apply. So it actually works a lot better when you start getting into multi-threaded environments where stuff can just be shoved on a queue. You don't have to think about threading. So maybe this has some
Closures?
Closures, yeah.
Go routines?
No, let's not go there. Close enough. But the thing is that I just see some synergy there. So maybe you don't. The distinction between cooperative and shall we call it coercive multiprocessing, may not need to make that distinction.
It's more apparent than real, perhaps?
No, I think this has potential outside of the single-threaded environment.
Ah.
That's what I'm saying.
Okay.
The programming paradigm, not necessarily this implementation.
Right, right. Okay. Christian?
Yeah, so I'm really interested. I talked to you before that because I have an extension which drives hardware, and it has to fire events and wait until the hardware finishes the request. And I would really appreciate a simple example that turns a callback-based interface into this kind of stuff. For example, like a fire event waiting simultaneously on 2 pipes.
Uh-huh.
Such a thing which highlights your ability to wait on multiple events. That would really ease, I think, implementation, because from the presentation it's still not completely clear to me what I have to do concretely to turn a callback-based interface into the new coroutine stuff.
This is all pretty fresh, and I even debated, whether I should present it yet. But I was excited enough to that I decided to. But I wrote this in May, or maybe April. So I think examples like that are forthcoming.
How does this relate to Roy Keane's stuff?
Pipe thread?
Yeah.
So let's see. Pipe thread is more about. I think it's lower level. Pipe thread is essentially an implementation of what you might do at a Unix command line in a TCL interpreter. I think this is probably something you might implement pipe thread in, for example.
Okay, so I would like now to start our lunch break, which we a little bit reduced time.